In this video, I'm going to be covering question 3, part A from the 2019 AP Calculus AB free response no calculator allowed portion of the test. I cover A, B, C, and D all in their own separate videos, so if you want to see any of those other solutions, please feel free to check out my other videos. In this problem, as soon as I see a graph on any AP calculus test, the first thing I want to do is make sure I know what that is the graph of. So what we're looking at up above here is the graph of f, the original function. Now that I'm aware of that, let's go see what this part A is actually asking us. It's saying if this integral from negative 5 to 6 of f of x dx equals 7. So notice that negative 6 is actually something not even on our graph. It's all the way out here. They're telling us that from negative 6 to 5 over here, that full integral, whatever that unpictured piece is going to give us a value of 7. Then they specifically want to know what's happening from negative 6 to negative 2 of f of x dx. So they're actually asking us to find this ungraphed portion here. What would the value of that integral be? Whenever I'm doing integrals like this, where it's portions of a larger section, I like to kind of pull this out and think about it in terms of a number line. So I start off and say, what's my full number line? Well, it would go from negative 6 to 5 over here. And what they've told me is that full integral across that whole space there, from negative 6 to 5 of f of x dx, that full integral is going to equal 7. Then I come back and start putting together the pieces that they asked for. So they want to know what's happening from negative 6 to negative 2. So they just want to know this portion of the number line here. What is the integral from negative 6 to negative 2 of f of x dx equal? Well, I can see that if I take that integral and add it to this side over here, that's going to give me my full integral. So if I take the integral from negative 2 to 5 of f of x dx and add it to that negative 6 to negative 2, that all added up should equal 7. So then I put together that integral formula. So I would say, okay, from negative 6 to 5 of f of x dx, that has to equal the piece that I'm looking for from negative 6 to negative 2 of f of x dx plus this other piece here, which is the actual graphed portion that I can see in the picture they gave me, f of x dx. So what we're going to do now is we're going to go ahead and find out what each of those integrals equals. The blue one and the brown one there, we already know the brown one, and we'll find out what the orange one actually equals. So coming back through, the integral from negative 6 to 5 of f of x dx, that was given to me. That's the full gap. That's 7. This integral here is what we're trying to find, so negative 6 to negative 2 of f of x dx. And now what you'll do is really what they're always kind of wanting you to do when they don't give you the actual equation, but you need to figure out what an integral is equal to, is they want you to use some standard geometry formulas to kind of figure out what it is that that area between the curve and the x-axis would end up being. So if we go and look at just that section, so if we're looking now just at the portion from negative 2 to 5, this piece right here, quickly you can kind of start getting rid of some of the work. Remember that you've got positive area above the x-axis. So from negative 2 to negative 1, that's a positive triangle right there. And then, you got to kind of be able to see that there's also then equal amount of negative space down below. So those two triangles are going to cancel each other out, and that's going to give us 0 for that portion. So we don't even need to calculate that. Then if I look from 0 there to 1, I can see I've got a negative little triangle that also has a friend over here in a positive shape that's going to cancel it out. So what I really need to focus in on right now is I need to find this area here, which that area there is going to be the area of a trapezoid. And the area of a trapezoid, that's a formula you've got to have memorized when you go into this test. This is 1/2 base 1 plus base 2 times the height. So when we think about it in terms of a normal trapezoid, we would have base 1 down here, base 2 is up here, and then the height is that gap. So looking at that portion, really what we have is we've got a trapezoid turned sideways. Our trapezoid is now looking up and down, so what we've got is the same type of idea, but our trapezoid is now kind of doing this. So base 1 would be here, base 2 would be there, and our height would be that gap coming across it. So putting that piece in, we would have 1/2. Base 1 is going to be what's happening right here at this edge, so that's going to be a height of 1. We add to that base 2, which is going to be this portion right here. And so base 2 goes up to 3, so plus 3. And then your height is going to be the gap across those two, so that would be 1. So that's that portion, which is pretty straightforward. The next piece that's a little bit more difficult to put together is going to be this piece right here. So when we get through this little section here, what you're going to notice, they tell us that this segment, you can see that little curved segment right there, they're telling us that this is a quarter circle. And so for us, we don't want the actual quarter circle portion. The quarter circle portion, right, would be if you kind of think about this right here, there's your radius, right? This is the quarter circle. But we don't want that piece of the puzzle. What we want is the other side of it. And so what you're going to need to do here is you're going to need to take this full area, this full square, this full rectangle right here, and you're going to subtract off of that the area of that quarter circle. And when we subtract from that full area, that quarter circle, now we're going to get that leftover space, which is what we want. And so here what you're going to do is you're going to add to this. This would be the full area of the rectangle. So that area of a rectangle is going to be base times height. So that full area there, the base on this would be from 2 to 5. So our base would be 3. The height would be right here. So that would be 3. So then the full area of that rectangle is going to be 9. What we need to subtract off of that is we need to subtract off of that the area of a quarter circle, which would be 1/2 pi times our radius squared. Well, the radius here, this is the radius across here. That's our r, that's 3. So we'd be looking at 1/4 pi times 3 squared. So we'd be looking at 9 pi over 4. So that's the full area of the quarter circle. Then to get our leftover piece, we're going to have to take the area of that rectangle, 9, and we're going to subtract off of that the area of our quarter circle, so 9 pi over 4. And what that's going to leave us with now is that's going to leave us with that purplish area down below here. That's the area that we're actually trying to find because that'll be what's left over. So we'll keep solving this because we need to find out what that integral is. So working through this, we get 7 equals, we don't know what this is. This is -6 to -2. That's what we want to find out. And now we start working through our calculations over here. So the 1 plus 3 would be 4. 4 times 1/2 is going to get us 2. And then on this other side, we're going to have plus 9 minus 9 pi over 4. And we're just going to kind of solve this like an algebra problem to get the integral that we want by itself. So I would go ahead and I would minus 2 and minus 9, minus 2, minus 9. That's like minus 11 right there. So 7 minus 11 is going to get us -4 equals our integral from -6 to -2 of f of x dx. And then we still have this piece here, our minus 9 pi over 4. And then we'll go ahead and now just add that over to the other side. So we'll get that integral by itself. We'll add the 9 pi over 4. And we're going to end up with -4 plus 9 pi over 4 equals this integral here, which is what we wanted in the end. And so that is our final answer. And they don't need you to combine those into a single fraction when you're doing this on the non-calculator allowed section. So we've got our final answer and we're done. So working our way back through this point-wise, how they would give you your points here is they would give you 1 point for setting up the fact that you knew that the full integral equaled those two integrals added together. You're going to end up getting out, finishing this out and getting this piece of the puzzle put together over here, putting together that integral using your geometry shapes. That's going to get you a point. And then in the end, you're going to get 1 point for getting together your final answer. So remember, when they want you to find the area between the curve and the x-axis, they're going to want you to use standard geometry shapes to do that. and that when you're dealing with integrals, think of them in terms of number lines and how you would kind of add or subtract pieces to get out what you need. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.